What draws a traveler across the gulf between stars to slip silently into our solar system and pass so near to Mars? In the vast ocean of darkness, stars hang like frozen sparks, their light scattered across an endless void. Against this backdrop, the planets circle the sun with patient precision, a fragile clockwork of orbits balanced on invisible threads of gravity. Yet into this delicate system comes an intruder, a visitor not born of our star, not bound by our history. Its name is 3I Atlas, the third interstellar object ever found. Before it came ʻOumuamua, a shard of mystery that left more questions than answers. Then Borisov, a comet whose icy breath revealed its foreign nature. Now once again the cosmos delivers a messenger from elsewhere. But this one does not simply pass by in the distance. Its arc carries it close to Mars as if drawn toward the red planet with uncanny intent. Is this a chance alignment, the outcome of pure mathematics written into celestial mechanics? Or is there something deeper, a hidden structure guiding these wanderers across the galaxy? Each trajectory becomes a whisper of forces not yet understood, hinting that interstellar visitors may not be random at all. As humanity watches, the question deepens. Why Mars? Why now? What message is carried in the path of this silent traveler? In its approach lies a riddle that blends science with wonder, chance with destiny, a mystery that invites us to look beyond the familiar borders of our world and to listen for meaning in the quiet footsteps of the cosmos. In the autumn of 2017, the night sky delivered a revelation that shook astronomy to its core. Astronomers at the Haleakala Observatory in Hawaii detected a faint streak moving across the darkness. At first, it seemed like countless other near-Earth objects charted before it. But within days, the truth emerged. Its trajectory was not an ellipse around the sun, not the gentle curve of a comet born of our own system. It followed a hyperbolic path, racing inward and then away at speeds too great for the sun to ever reclaim. This object was named 1I ʻOumuamua. The I stood for interstellar. Its name, drawn from the Hawaiian language, meant scout or messenger from afar. The choice was fitting. For in a single stroke, ʻOumuamua confirmed something that had long been theorized but never seen. Pieces of distant planetary systems do not remain confined to their stars. They drift outward, cast loose into the void, and some of them eventually cross our path. The discovery overturned assumptions. For decades, astronomers speculated that fragments from the birth and death of planets must wander the galaxy, but such objects were expected to be vanishingly rare. Our telescopes, it seemed, were too limited. The odds of spotting one in a human lifetime were thought to be remote. Yet here it was, streaking through our backyard. The mystery deepened as more data was gathered. ʻOumuamua was small, no more than a few hundred meters long, with an elongated shape unlike any asteroid ever studied. It reflected light in strange ways, as though its surface bore an unusual composition, and most puzzling of all, it exhibited a slight acceleration as it receded from the sun, too subtle to be explained by gravity alone. No visible tail of dust or gas accompanied it, leaving open the question of what mechanism propelled it forward. Speculation spread far beyond astronomy journals. Some proposed that it was a fragment of nitrogen ice, similar to Pluto's frozen surface sublimating under sunlight. Others suggested it might be an exotic shard of hydrogen ice, or a sliver of carbon-rich material unknown in our system. Still others, more daring, wondered aloud if it could be an artifact of technology, a sail-like construct adrift between the stars. Whatever its origin, one truth was undeniable. Our solar system had been visited by something from elsewhere, and its nature remained elusive. 2 years later, the cosmos delivered a second messenger. In late August 2019, amateur astronomer Gennady Borisov peered through a homemade telescope in Crimea and discovered a glowing smear of light. Unlike ʻOumuamua, this object displayed an unmistakable tail, the signature of a comet. Designated 2I Borisov, it was the first interstellar comet ever observed. Its orbit confirmed what its appearance suggested. It too was a wanderer from beyond. Borisov offered a different kind of revelation. Whereas ʻOumuamua had been enigmatic, featureless, and silent, Borisov behaved more like the comets long known to humanity. It released cyanide gas and water vapor, much like those that have circled our own sun for billions of years. Spectroscopic analysis showed that its ices were similar, though not identical, to local comets. hinting that the processes of planetary formation may follow universal rules. In Borisov's tale, astronomers glimpsed a bridge between worlds, evidence that planetary systems across the galaxy produce familiar materials, and that fragments of those worlds drift freely through interstellar space. The detection of two such objects in quick succession forced a re-evaluation of cosmic probabilities. If one interstellar visitor could be dismissed as extraordinary luck, two demanded a new perspective. The galaxy, it seemed, was teeming with debris cast off from the birth and death of planets. Our telescopes were only just beginning to glimpse them. Yet finding these objects remained extraordinarily difficult. Interstellar visitors move swiftly, often faster than 30 kilometers per second relative to the Sun. They arrive unannounced, faint and distant until they are already rushing inward. By the time they are bright enough to notice, they are often speeding away again, beyond the reach of detailed study. For every ʻOumuamua or Borisov detected, countless others must have passed unseen, silent streaks in the dark. Astronomers began to prepare. Surveys such as the Pan-STARRS program in Hawaii and the Catalina Sky Survey in Arizona scoured the skies nightly, searching for the faint signatures of moving objects. Future observatories like the Vera C. Rubin Observatory in Chile promised to widen the search further, capturing the entire visible sky every few nights. The age of discovery was accelerating, driven by a realization: interstellar debris is not rare. It is common, and our instruments are finally sensitive enough to find it. Then, in 2020, came a third revelation. Observers tracking faint objects near the edge of the solar system flagged something unusual. At first, it was catalogued as a comet by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a survey designed to detect potential hazards to Earth. Its path was puzzling. As more data was gathered, astronomers realized it was no ordinary comet at all. Its orbit was hyperbolic, with an eccentricity greater than 1, ensuring that it was not bound to the Sun. This was the third confirmed interstellar object. Its designation became 3I Atlas. Unlike its predecessors, 3I Atlas carried a trajectory of particular intrigue. Calculations showed that its path would swing unusually close to Mars. While interstellar visitors can pass anywhere through the solar system, the odds of one aligning so near to a major planet are vanishingly small. The scientific community took notice. Once again, the cosmos had delivered not only a wanderer, but a riddle: 3 interstellar objects in less than a decade. The implications were profound. For centuries, humanity had gazed outward and wondered what else might drift in the spaces between stars. Now the answer was arriving faster than anyone had predicted. Each visitor brought with it a fragment of history from another system, clues etched into rock and ice, into chemistry and motion. Each one transformed the solar system from an isolated island into a crossroads of galactic debris. Astronomy had entered a new era. The universe was not merely something observed from afar, but something that sent pieces of itself directly into our reach. And with 3I Atlas, a new question emerged. Why did this one pass so close to Mars? Was it coincidence or a sign of patterns in interstellar space yet to be understood? The legacy of interstellar visitors was no longer confined to speculation. It was being written into the fabric of science itself. The silent approach of these travelers was reshaping how humanity sees the galaxy, not as a distant spectacle, but as a place in which our own solar system is woven into a greater web of motion, connection, and mystery. As 3 Atlas arced inward, scientists prepared. Instruments across the world and in orbit turned their gaze to this fragile traveler. Every observation would matter, for once again the chance would not come again. The path of an interstellar visitor is fleeting. It arrives, it whispers its secrets for a moment, and then it vanishes into the dark, leaving behind only questions, data, and wonder. And so the story of 3I Atlas began, built upon the legacy of those who had come before. From ʻOumuamua, the enigmatic messenger, to Borisov, the familiar yet foreign comet, each had prepared us for this moment. Each had taught us to watch more closely, to expect the unexpected, to understand that our solar system is not an isolated harbor, but a shore upon which the tides of the galaxy occasionally deliver their driftwood. Now a third messenger was here. Its destination, a close approach to the red planet. Its meaning still uncertain. Its presence undeniable. The legacy of interstellar visitors was no longer the stuff of speculation. It was unfolding in real time, reshaping the way humanity perceives the boundaries of its own cosmic home. In the language of the heavens, every path is written in numbers. Orbital elements define the story of motion. Eccentricity, inclination, perihelion distance, each parameter a syllable in a sentence composed by gravity. When astronomers turned their gaze toward 3I Atlas, these numbers unfolded into a tale unlike those of ordinary comets and asteroids. The first calculations confirmed what had already been suspected. Its orbit was hyperbolic with an eccentricity greater than 1. This was the unmistakable signature of an interstellar object. Nothing bound to the sun could move in such a way. It had not formed here. It had arrived from elsewhere, carrying with it the momentum of another star's domain, its velocity at infinity, what astronomers call the speed it retains even after escaping the sun's pull was estimated to be over 30 kilometers per second, comparable to ʻOumuamua and Borisov. This speed revealed both its ancient journey and its fleeting presence. It would not linger. It would slice across the solar system in a single passage, an arc of weeks and months set against billions of years. Yet the path it carved was not ordinary. Unlike ʻOumuamua, which had rushed past Earth, or Borisov, which threaded through the outer regions, 3I Atlas curved inward with a trajectory that would bring it into a striking proximity with Mars. Not a collision, but a passage so near that orbital simulations drew the line of its motion, brushing the edge of the red planet's gravitational influence. Mars, a world that has always stirred human imagination, now found itself at the center of a cosmic alignment. To visualize the geometry is to imagine a vast stage, the sun burning at the center, the planets sweeping in their ellipses like dancers circling a fire. And into this choreography comes a stranger, tracing a path that seems improbably attuned, sweeping past the orbit of Earth and sliding into a near encounter with Mars. For astronomers, this was more than coincidence. The odds of such an approach are vanishingly small. Interstellar visitors are expected to arrive from random directions, their paths distributed like grains of sand cast into the wind. Most sweep past the outer solar system never noticed. Some are pulled inward, but the chance alignment required to pass so near a planet is extraordinary. That it should happen with Mars of all worlds added to the intrigue. To understand the strangeness, one must consider Mars' gravitational sphere of influence. Every planet carves out such a domain, a region where its gravity exerts dominance over passing bodies despite the sun's overwhelming mass. For Mars, this sphere extends millions of kilometers outward, delicate compared to Earth's but still significant. To enter this sphere is to be subtly deflected, to feel the planet's tug bending one's trajectory. Simulations showed that 3I Atlas would skim this invisible boundary. It would not be captured, its velocity was far too great, but its path would bear the fingerprints of Mars's pull, a measurable shift written into its outbound course. The geometry was exquisite, a cosmic brushstroke laid down by gravity itself. Scientists began to map the encounter in precise terms. Orbital diagrams plotted the arcs of planets and the intruder, glowing threads weaving across black backgrounds. In these models, the difference between a random flyby and this precise curve was stark. Random interstellar objects, when simulated, tend to miss planets entirely, their hyperbolic paths cutting through the solar system with little regard for planetary positions. But here the lines converged. Mars and 3I Atlas, two tiny points against a vast sky, poised for a near passage separated by a margin of cosmic chance. The question arose, was this merely fortune? A roll of celestial dice that happened to fall in such a way? Or was there more? Some scientists remained cautious. Statistics, after all, are complex in a galaxy filled with uncountable wanderers. Given enough time, improbable alignments must eventually occur. But others were compelled by the elegance of the trajectory. They asked whether interstellar debris might be guided not just by chance but by hidden currents of galactic dynamics. To explore this possibility is to step beyond certainty and into speculation. The Milky Way is not a static void. It is a sea of gravitational waves and perturbations, a place where the tides of stars, dark matter, and galactic structure impose subtle order on drifting objects. Could these influences nudge debris in ways that increase the likelihood of planetary encounters? Could there be unseen patterns written into the background of the galaxy that shape where these wanderers appear? Such questions remain unanswered. Yet the path of 3I Atlas brought them into focus. For the first time, astronomers could watch as an interstellar object engaged directly with a planet's gravitational sphere. The encounter promised data not just on the object itself, but on the fundamental mechanics of how interstellar bodies move when they enter planetary systems. As the object approached, telescopes tracked its position with relentless precision. Each night of observation refined the orbital elements, adjusting the diagrams, sharpening the predictions. The velocity, the angle, the deflection, all became clearer with time. To the human eye, the difference was imperceptible, but to the mathematics of orbital dynamics, it was a story of gravitational whispers, of Mars reaching out across millions of kilometers to leave its mark on a traveler that would never return. Visualizations captured the imagination. Animated models showed 3i Atlas sweeping inward, a thin white line curving past the red dot of Mars, then bending outward once again toward the interstellar night. The contrast between randomness and precision was striking. Without Mars, the path would have been a smooth hyperbola, elegant in its simplicity. With Mars, it became something richer, an interaction, a dialogue between worlds across an immense distance. For those who study celestial mechanics, this was a chance to test theories of gravitational scattering. Every encounter between a planet and a passing body can alter trajectories in measurable ways. In our own system, this principle has been harnessed deliberately. Spacecraft like Voyager and Cassini have used planetary flybys to steal momentum, slingshotting outward to reach their destinations. Here, the same principle played out on a cosmic scale. A fragment from another star's nursery would feel Mars's tug and carry that subtle influence with it back into the galaxy. The philosophical weight of the alignment was undeniable. Mars has long been a mirror of human ambition and curiosity. It has been seen as a potential second home, a world both familiar and alien. Now it was cast into a new role, as a participant in a rare celestial choreography. An interstellar visitor indifferent to our dreams would pass close enough to touch Mars with gravity alone, as though the planet itself had been chosen as the stage for this encounter. Scientists prepared for the moment, not as an opportunity for direct exploration. The object was too small, too faint, too swift, but as a moment of insight. Every photon captured, every astrometric measurement, would refine the understanding of how interstellar visitors behave in planetary systems. These data would ripple forward, informing future detections, shaping strategies for observing the next wanderer. Yet beyond the science, there was the sense of mystery. Why Mars? Why this trajectory? Why should the third interstellar object ever observed in human history pass so close to the planet that has always haunted human imagination? Chance is the simplest answer. But even chance, when framed against the backdrop of cosmic scale, acquires an almost poetic resonance. For the universe does not conspire with intent. It moves in patterns set by gravity, by energy, by the immutable laws of physics. And yet in those patterns meaning can be found. Coincidence itself becomes part of the mystery, inviting reflection on the improbable alignments that give shape to existence. The trajectory of 3i Atlas was a reminder of scale. A speck of rock and ice from another star system, invisible to the naked eye, arriving across light years only to brush the gravitational field of a single planet, a planet that humanity has chosen as a symbol of its own future. Such alignments do not need purpose to stir wonder. They simply are. And in their unfolding, they reveal how deeply connected the universe truly is. As astronomers plotted the final models, the image was clear. A hyperbola, distorted at the edge by Mars's invisible hand, carrying the object past the planet and out once more into the void. Not captured, not held, but marked. Its outbound path forever altered by a brief encounter with a world it would never touch. This was the geometry of chance, the poetry of physics, the story of how a visitor from the stars came to brush against the orbit of Mars. And in that brush lay a mystery that would outlast its passage. A reminder that every trajectory, no matter how fleeting, is part of a grander pattern, one that humanity is only beginning to read. In the mathematics of the heavens, coincidence is a word rarely used lightly. Each orbit, each encounter, each trajectory is the outcome of immutable laws written into the structure of space and time. And yet, when astronomers calculated the path of 3i Atlas, they found themselves lingering on the question of chance. For what were the odds that an interstellar traveler, arriving from the boundless directions of the galaxy, would thread its way into such close proximity with Mars? To answer, scientists turned to probability. They modeled countless possible intrusions of interstellar debris into the solar system, running Monte Carlo simulations that randomized velocities, approach vectors, inclinations. Each virtual object entered as a messenger from the void, bound to no star, governed only by the distribution of trajectories that the galaxy might allow. The results showed what intuition already suggested. Most paths did not touch the inner solar system at all. The majority swept through the periphery, grazing the orbits of Jupiter or Saturn unseen and unremarked. Only a fraction, a vanishingly small fraction, strayed inward to the terrestrial planets. And of those, the chance of aligning within the sphere of influence of Mars was slimmer still. Mars is not a gravitational giant. Compared to Earth, its reach is modest, its mass insufficient to dominate its region of space. For a hyperbolic interstellar visitor to pass within its invisible boundaries is a statistical rarity, akin to a grain of cosmic dust landing upon a single pebble in a desert. Yet 3I Atlas, among the first 3 interstellar objects ever discovered, traced precisely this path. Some dismissed it as the inevitable outcome of large numbers. The galaxy is filled with debris, ejected during the violent births and deaths of planetary systems. Over billions of years, countless objects must cross our star's domain. Most remain unseen. The 3 we have detected are not exceptional, they argue, but simply the few fortunate enough to be caught by our eyes. Given enough opportunities, even rare alignments will occur, but others hesitate. The elegance of the curve, the intimacy of the passage, stirs unease. The very first generation of interstellar detections has already delivered not one, but 2 profound enigmas. First was the unexplained acceleration of ʻOumuamua, a body that seemed to defy all conventional models of comets and asteroids. Now comes Atlas, threading the needle of probability to sweep close by Mars. To some, these alignments feel less like noise and more like the faint outline of a deeper geometry. It is here that science brushes against philosophy. Randomness is not disorder. In physics, randomness emerges from distributions, from the spread of outcomes allowed by the rules of motion. But when improbable outcomes manifest repeatedly in ways that carry symbolic resonance, visitors curving near the planet that humanity has long chosen as its destination, wonder grows restless. Minds begin to ask whether there is something hidden beneath the surface of chance. The debate echoes the earlier controversies surrounding ʻOumuamua. When the anomalous acceleration was first observed, explanations abounded. Perhaps it was outgassing, though no coma was visible. Perhaps it was shaped like a pancake or a shard, catching solar radiation in subtle ways. Others ventured that it might be a fragment of exotic ices, invisible in their sublimation. And beyond those natural models, one suggestion cut through the noise like a blade. Could it be artificial? Could its trajectory and its peculiar acceleration be explained not by randomness but by design? The proposal was controversial, embraced by few but considered by many. Avi Loeb of Harvard argued that the simplest explanation was an artificial light sail, a relic of technology adrift between stars. The claim ignited debates that spilled far beyond astronomy. Some dismissed it as unnecessary speculation, a leap too far beyond evidence. Others acknowledged that extraordinary anomalies demand extraordinary openness. The truth remains unsettled, suspended between interpretations. With Atlas, the puzzle is different, but the spirit is the same. If ʻOumuamua tested the limits of physical explanation, Atlas tests the boundaries of probability. What is the threshold at which coincidence becomes remarkable? How rare must an event be before it demands not just acceptance but reflection? Monte Carlo simulations are cold in their language. They assign numbers to rarity. They chart distributions that stretch across millions of possibilities. When they declare that an alignment is unlikely but not impossible, they capture the mechanics but not the poetry. For to human minds, rarity carries weight. A roll of dice, a shuffle of cards, a fall of stones. These events stir us because improbable outcomes remind us of the delicate balance between order and chance. The cosmos, in its silence, whispers through such alignments. Mars, long considered humanity's future frontier, now stands as the pivot of this improbability. Its red deserts have been imagined as cradles of life, its valleys mapped as destinations for explorers yet unborn. And now into that narrative comes an interstellar traveler, brushing so close that astronomers cannot help but notice. Coincidence alone explains it. Yet the resonance of the event pushes thought toward metaphor. The universe, indifferent yet intricate, seems to fold human dreams into its random scattering of debris. The question then becomes, how does one distinguish coincidence from hidden order? Physicists remind us that randomness often masks deeper patterns. The Brownian motion of dust and water appears chaotic until revealed as the outcome of countless unseen collisions. The orbits of planets once seemed erratic until Newton unveiled the underlying force. In the same way, could the trajectories of interstellar objects conceal a geometry not yet perceived? One candidate lies in galactic structure. The Milky Way is not uniform. Stars cluster in arms. Gravity wells ripple through its disk. Dark matter shapes its halo in ways only partially understood. Within this framework, streams of debris may form, flowing like invisible rivers through interstellar space. If Atlas belongs to such a stream, its trajectory may not be random at all, but the outcome of currents that bend wanderers toward certain alignments. The close pass by Mars would then be less of a miracle and more of a revelation, that the solar system lies within a corridor of galactic traffic, and that Mars happened to be the planet aligned to intercept it. Speculation? Yes, but grounded in precedent. Astronomers have already identified stellar streams, relics of ancient galaxies consumed by the Milky Way, their stars still flowing together across the sky. Could similar patterns exist for interstellar fragments, their paths synchronized by forces far larger than themselves? Whether coincidence or geometry, the implications are profound. If random, then humanity has simply been lucky, granted early encounters that open a window into galactic processes. If patterned, then a deeper order lies waiting to be uncovered, one that could reshape the way we view not only visitors like Atlas, but the structure of the galaxy itself. In either case, the mystery grows. 3 interstellar objects in less than a decade, 2 of them carrying enigmas sharp enough to ignite debate. Each new discovery rewrites the expected frequencies, challenging the models of rarity that once framed human expectations. Astronomy, like philosophy, finds itself suspended between 2 truths. The universe obeys its laws without exception, and yet within those laws the improbable unfolds with startling clarity, inviting meaning where none is required. The passage of 3I Atlas near Mars is one such unfolding. A hyperbolic arc, a deflection measured in fractions of degrees, an event that probability deems unlikely yet reality confirms. Whether it is coincidence or cosmic geometry, the effect upon human thought is the same. It expands the imagination. It deepens the sense of connection between planets, stars, and the fragments that drift between them. As debates continue, one certainty remains. The universe is far stranger and far more generous than human models predict. Each time we believe we have bounded its probabilities, it delivers alignments that seem tailored to provoke wonder. Each time we insist that randomness explains all, it confronts us with outcomes that stir the suspicion of hidden design. The razor's edge between chance and order is where science thrives and where philosophy blooms. The legacy of ʻOumuamua lingers in this. Its unexplained acceleration remains an unsolved riddle, a reminder that our tools are still too crude to capture every secret. Atlas now joins that legacy, not in its physics but in its improbability. Both carry us to the same precipice, the place where scientific rigor meets human awe, and where the cosmos itself seems to ask questions without words, coincidence or geometry. Randomness or pattern. The universe does not answer. It simply reveals one visitor at a time, and in those revelations, humanity is left to wonder whether each passing traveler is a messenger of chance, or a signpost pointing toward a hidden structure, waiting to be unveiled in the quiet depths of interstellar space. Every motion in the universe is a conversation between matter and force. Objects do not drift alone. They move under the guidance of fields, the pull of gravities, the subtle whisper of radiations, and the deep structure of space-time itself. The trajectory of 3I Atlas, like every body that has ever crossed the solar system, is the product of this dialogue. To trace its path toward Mars is to unravel the invisible hands that have shaped its journey. The greatest sculptors of motion in our planetary system are the giants, Jupiter and Saturn. Their gravity wells loom like titanic vortices in the ocean of space. Jupiter, in particular, with its immense mass, commands a domain that stretches across millions of kilometers, a presence so vast it can alter the course of comets that wander too near. Astronomers often describe it as a gatekeeper, diverting some objects into harmless orbits while flinging others outward into exile. Without Jupiter, the solar system would be far less stable, its inner planets bombarded by a ceaseless hail of debris. Saturn plays a quieter but no less meaningful role. Its gravity well adds nuance to the architecture, shaping resonances that echo across the system. Together, the two giants stand as twin sentinels, their influence woven into the very rhythm of planetary evolution. Interstellar objects passing through the system cannot avoid their pull. Even when distant, their trajectories feel the giants' weight, bending subtly in ways that reshape their outbound paths. Mars, by comparison, is modest, yet its role in the case of Atlas cannot be ignored. Its smaller gravity well is dwarfed by those of its larger siblings, but it lies directly in the intruder's way. As Atlas swept past, Mars reached out invisibly, shifting the line of motion by degrees so fine that only precise instruments could perceive them. Yet these small deflections matter. In celestial mechanics, a fraction of a degree can decide whether a body is captured, scattered, or set adrift on a new arc that will echo for millions of years. Gravity alone does not tell the whole story. Some forces are subtle yet insistent, and over time they accumulate into profound effects. Radiation pressure, for instance, may seem insignificant when measured against the weight of planets. Yet every photon of sunlight carries momentum. When billions upon billions of them strike the surface of an object, they push. For large bodies, this effect is negligible. For small, fragile fragments, it can shape orbits in measurable ways. The Yarkovsky effect builds on this principle. As sunlight warms one side of a rotating body, the delayed release of heat creates a tiny thrust. The effect is minute, but relentless, altering asteroid paths across decades and centuries. Even the smallest rocks drifting through the solar system carry the imprint of this thermal dialogue with the sun. For interstellar objects like Atlas, radiation and heat may leave their own marks, though the brevity of their passage means the changes are slight. Still, slight does not mean irrelevant. When motion is measured with the precision of modern astronomy, every whisper of force becomes part of the narrative. Outgassing provides another layer of complexity. Comets within the solar system often vent jets of gas and dust as sunlight boils their ices. These jets act like thrusters, pushing the nucleus unpredictably, shifting its path in ways gravity alone cannot account for. Borisov, the second interstellar object, revealed such behavior clearly, with tails and plumes that betrayed its icy heart. Atlas, by contrast, has not displayed such obvious activity. But even faint sublimation, invisible to telescopes, could be at work, nudging its hyperbolic arc as it approaches and retreats. Beyond these visible influences lies the deepest force of all, the curvature of space-time. Einstein's general relativity teaches that gravity is not merely a pull, but a warping of the very stage upon which all objects move. Mass bends the geometry of space and time, and within that geometry objects follow the straightest possible lines, which to us appear as curves. The trajectory of Atlas is one such geodesic, shaped by the combined masses of sun, planets, and everything else in its vicinity. When astronomers draw orbital diagrams, they flatten this curvature into simple arcs. But the truth is more profound. Atlas is tracing not a line through emptiness, but a path along the folded fabric of reality itself. This understanding reframes even the smallest deflection. When Atlas bends near Mars, it is not merely pulled but guided through a valley in space-time carved by the planet's mass. When it accelerates past the sun, it is not tugged but funneled through the deep well of the star's geometry. In relativity, every orbit, every flyby, every hyperbola is the natural unfolding of shape in a universe where space and time are malleable. To watch Atlas move is to watch space-time reveal its contours. Yet the visible forces may not be the whole story. The cosmos is not made only of what can be seen. Dark matter, invisible yet dominant, outweighs all stars and planets combined. It shapes galaxies, holds clusters together, and defines the motions of stars across the Milky Way. Though dark matter interacts little with ordinary matter, its gravity is real, its presence undeniable. Could it also touch the paths of interstellar debris? If dark matter is smoothly distributed, then its effect on a lone traveler like Atlas would be diffuse, blending into the background pull of the galaxy. But if dark matter clumps, if it forms filaments or clouds unseen, then perhaps interstellar wanderers cross through them as they journey. Each passage could leave a trace, a subtle nudge, a deviation too small to isolate yet real enough to accumulate across light years. The path of Atlas might then carry the imprint of structures humanity cannot yet detect. Its arrival near Mars might be less coincidence, more the end of a journey guided by invisible scaffolding. Speculation extends even further. Some physicists imagine modifications to gravity itself, alternatives to dark matter that reshape the rules of motion at galactic scales. If such theories hold truth, then every interstellar visitor is not just a fragment of rock and ice, but a probe of fundamental physics. By charting their paths with exquisite accuracy, astronomers test whether Newton and Einstein fully described the universe, or whether deeper laws wait to be uncovered. Atlas, in this sense, becomes more than an object. It becomes an experiment written by the galaxy itself, unfolding across the solar system's stage. What is striking is how many layers of force converge on a single fragment. From the immense pull of Jupiter, to the modest influence of Mars, to the gentle push of photons, to the curvature of space-time, to the potential guidance of unseen matter, each plays a role in shaping the journey. The path of Atlas is not random but orchestrated, a melody composed of interactions that span the spectrum from the tangible to the theoretical. And within this orchestration lies reflection. If every force shapes the path, then no motion is meaningless. Each deflection, each subtle bend, carries within it a record of the universe's structure. The trajectory of an interstellar visitor is not just a line across a chart. It is a story written in gravity and light, in heat and geometry, in the silent dialogue between visible and invisible realms. Astronomers, in their calculations, distill this complexity into orbital elements, numbers that summarize position, speed, inclination. Yet behind those numbers lies the grandeur of physics itself. Atlas, sweeping near Mars, embodies the entire history of cosmic interaction. From the birth of planetary systems that expelled it, to the galactic environment it drifted through, to the planetary stage upon which it now performs its brief passage. The forces that shape the path remind us that nothing in the cosmos is truly isolated. Every particle of dust, every wandering stone, every interstellar visitor is part of a network of relationships extending outward into infinity. To study Atlas is not simply to chart its course, but to glimpse the architecture of reality, an architecture built from gravity wells warmed by radiation, curved by relativity, and perhaps framed by invisible matter. The mystery is not whether these forces act. They do, and their mathematics is well understood. The mystery lies in their resonance. Why this path? Why this alignment? Why Mars? Each force may explain the mechanics, but together they raise a question of meaning. The cosmos is indifferent, yet its indifference takes the shape of patterns so elegant that they seem almost intentional. In the end, the forces that shape the path do more than guide the motion of rock and ice. They shape human thought. They remind humanity that its own existence too is an outcome of forces. Gravity binding a planet together, sunlight warming oceans, invisible matter holding the galaxy in its arms. The passage of Atlas near Mars becomes not just an astronomical event, but a mirror, a reminder that every journey, whether of a stone across the stars or of a species across time, is sculpted by the same universal laws. Among all the planets that circle the sun, none has captivated human imagination like Mars. It glows in the night sky as a steady ember, its reddish hue unlike any other. To ancient peoples it was the god of war, a celestial sign of conflict and fire. Babylonian scribes marked its path through the constellations. Roman generals prayed beneath its glow, and poets through the ages linked it to passion and unrest. Mars has always carried more than physical presence. It has been a symbol, a projection of the human spirit onto the heavens. Yet as telescopes sharpened, the myth grew entangled with science. In the 19th century, astronomers reported faint lines crossing the Martian surface. Giovanni Schiaparelli called them canali, channels, though mistranslation turned them into canals. To the popular imagination, this was proof of engineering, evidence of intelligence shaping another world. Speculation bloomed, a dying civilization desperate for water, etching vast aqueducts across the deserts of Mars. The idea was later dispelled, but it left an imprint, seeding the modern notion that Mars is more than a barren rock. It is a place that might have once lived. Modern science paints a subtler but no less compelling picture. Robotic explorers have found dried riverbeds, mineral veins that form only in liquid water, and sediments layered by ancient lakes. The thin atmosphere of Mars today cannot sustain oceans, but billions of years ago, its surface may have been blue with seas. The red planet is dry now, scoured by dust storms and frozen plains, yet it bears scars that whisper of a wetter, warmer past. A past that might have harbored microbes clinging to niches of possibility. For this reason, Mars has become more than an astronomical curiosity. It is a scientific frontier, the most promising candidate for life beyond Earth in the near solar system. If life began there, even at the microbial scale, then it may have begun twice within a single star system. Such a discovery would transform humanity's understanding of its place in the cosmos, proving that biology is not a rare spark, but a natural flame that ignites wherever conditions allow. But Mars is not only a mirror for science. It is a mirror for longing. Since the dawn of space exploration, it has represented the next step outward. The Moon was a milestone, but Mars has always been the destination where permanence might be forged. Visionaries have imagined colonies beneath domes, terraformed landscapes, green valleys carved into rust-red deserts. Even now, engineers plan spacecraft that might carry humans there within a generation. To reach Mars is to transform humanity from a planetary species into a multi-world civilization. This duality, scientific promise and cultural resonance, makes Mars unique. Venus is too hostile, with its crushing pressures and infernal heat. Mercury too barren, too close to the sun's blaze. The gas giants are distant storms, their moons intriguing but secondary. Only Mars stands close enough, mild enough, evocative enough to be a true mirror of human destiny. Into this context enters the trajectory of 3I Atlas, an interstellar traveler, silent and ancient, brushing past the planet that has always been the focus of human dreams. Coincidence alone might explain it. The galaxy is vast, the solar system dynamic, and improbable alignments must eventually occur. Yet the symbolism is impossible to ignore. The third interstellar object ever confirmed arrives not to skim Earth, nor Venus, nor the far reaches of Jupiter, but to pass close to Mars. The timing feels uncanny. Arriving in an era when Mars dominates the human imagination more than at any other point in history. Such reflections are not scientific conclusions, but they are part of the narrative that shapes perception. For astronomy does not exist in a vacuum. Observations are interpreted through human thought, and human thought is steeped in meaning. When a fragment from another star system brushes past the red planet, it resonates differently than if it had passed elsewhere. It feels as though the cosmos itself has drawn attention to the place humanity has long chosen as its next home. Mars, in this sense, is not just a planet. It is a screen upon which human aspiration is projected. To look at Mars is to see not only rust-red deserts and frozen craters, but also reflections of human stories. War and longing, science and destiny, exploration and survival. In this way, the red planet becomes a cosmic mirror. The mirror is both literal and symbolic. Literally, Mars reflects sunlight back to Earth, its reddish glow visible to the naked eye. Symbolically, it reflects the deepest currents of human ambition. It shows what humanity wishes for itself, to go beyond, to endure, to plant life where once there was none. When Atlas passes by, its silent curve near Mars becomes woven into that reflection. It is as if the universe has momentarily aligned the story of the stars with the story of human hope. Science insists on caution. The trajectory of Atlas can be explained entirely by physics, by gravitational alignments and celestial mechanics. The path is extraordinary, yes, but not impossible. To read meaning into it is to step beyond the realm of data into the realm of interpretation. Yet interpretation has always been part of the human response to the sky. The ancients saw gods in the planets. Modern humanity sees futures. Perhaps both reflect the same need, to find connection in the immensity of space. The encounter raises questions not of mechanics, but of perspective. Why does the passage of a small interstellar object near Mars stir such depth of thought? Because Mars itself carries weight. The same event near Neptune would pass without resonance. Near Earth, it might provoke fear, but near Mars it evokes wonder. This is the power of symbols. They transform coincidence into story, and story into meaning. Philosophically, the event becomes a meditation on destiny. Mars represents not what humanity is, but what it might become. The presence of Atlas there, fleeting though it is, reinforces that image. It reminds us that even as wanderers from other stars drift through, the red planet remains the stage upon which humanity's next act may be written. There is another layer of reflection. Mars itself has been shaped by forces similar to those that shaped Earth. Both worlds began with liquid water, volcanic vigor, and atmospheres capable of supporting change. One retained these gifts, the other lost them. To study Mars is to hold a mirror up to Earth, to ask what preserved habitability here and what stripped it away there. The answer carries implications not only for the search for life elsewhere, but for the stewardship of life here. Atlas, by passing near Mars, joins this dialogue. Its presence is not active, not intentional, but symbolic. A traveler from another system, moving through the solar system at the moment when humanity contemplates its expansion, drifts close to the very world chosen as the next frontier. Science explains the mechanics, but philosophy lingers on the resonance. Could the universe be reminding humanity of its chosen path, not through intent but through the poetry of coincidence? The red planet, glowing faintly in the night, becomes both destination and mirror. In its deserts, humanity sees its fragility. In its valleys, humanity imagines its resilience. And in the passing of 3i Atlas, humanity is reminded that it is not alone in motion. Across the galaxy, countless other fragments drift, silent witnesses to the vastness of existence. Their paths cross ours not to deliver messages, but to remind us that the universe is alive with motion and connection. Mars, the god of war, the dream of explorers, the target of science, and now the focus of an interstellar alignment. More than just a planet, it is a mirror of longing, of destiny, of the human desire to find meaning in the stars. The approach of Atlas may be chance, but within that chance lies a reflection powerful enough to transform perception. The light from an interstellar visitor is faint, fragile, and fleeting. For astronomers, every observation becomes a race against time. The object sweeps inward, brightens briefly as it approaches the sun, and then fades once more into the dark. In those weeks or months of visibility, the only tools are photons, tiny messengers of reflected sunlight that carry hints of what the traveler is made of. From those whispers, astronomers attempt to reconstruct an alien history. With 3i Atlas, the challenge was no different. Telescopes gathered its light from mountaintops and orbiting observatories, converting faint specks into data. Photometry revealed its brightness curve, offering clues to its size and reflectivity. Spectroscopy split its light into bands, searching for absorption lines, for signatures of ices, minerals, or organic compounds. The results, though incomplete, began to sketch a portrait of its nature. Its brightness suggested a small body, perhaps a kilometer across, though uncertainties remained large. Albedo, the measure of reflectivity, hinted that its surface was darker than fresh ice, more akin to carbon-rich asteroids or comets coated with space-weathered dust. Such darkness is common among bodies that have drifted for eons in interstellar space, their surfaces bombarded by cosmic rays, chemically altered by ultraviolet light, and scarred by micrometeoroids. What had once been bright could, over millions of years, be transformed into a muted husk. Spectral data provided further intrigue. The light did not display the sharp emission lines of an active comet venting gases, as Borisov had, nor did it behave exactly like the rocky, inert asteroids familiar from the solar system. It seemed to lie in between, ambiguous, elusive. Some readings suggested subtle hints of volatiles, frozen substances that might sublimate with greater heating. Others leaned toward a more refractory composition, dominated by rock and metal. In truth, the evidence was inconclusive, reminding astronomers that nature resists simple categories. The ambiguity left open possibilities. Perhaps Atlas was once a cometary body, its ices largely exhausted by previous passages near stars. In this interpretation, what remained was a core stripped of activity, a remnant of a more volatile past. Or perhaps it was a fragment of an exoplanet, a shard torn free during the chaotic formation of some distant system, wandering for eons before drifting into ours. Each scenario carried profound implications. Comparisons to the solar system offered context, Comets from the Oort cloud, when they fall inward, often reveal a wealth of volatiles: water, carbon dioxide, ammonia, released in spectacular tails. Their surfaces are dark, but their activity betrays their icy hearts. Asteroids, by contrast, remain silent, reflecting sunlight with stony consistency. Atlas echoed both categories without fully belonging to either. It was darker than most asteroids, less active than most comets, and more enigmatic than either. Some astronomers suggested that such ambiguity may be the rule, not the exception. Interstellar objects, after all, have histories utterly unlike those of the solar system. They are born in alien cradles, shaped by alien suns, scattered by gravitational upheavals in planetary nurseries we will never see. Each fragment carries within it the memory of its system of origin, the chemistry of its star, the architecture of its planets, the violence of its ejection. To study them is to study the diversity of planetary formation across the galaxy, compressed into tiny, silent stones that wander into our reach. The philosophical weight of this realization is immense. Every interstellar object is not merely a rock or a comet. It is a fossil, a fragment of a world that may no longer exist. Perhaps Atlas was once part of a planet's crust, shattered in a cataclysmic collision. Perhaps it was an icy body that circled its star for billions of years before being flung outward by a migrating giant. Perhaps it drifted near supernova remnants, its chemistry altered by radiation from an exploding sun. Each scenario is a history book written in minerals and ices, though one humanity can read only from afar. The comparison to ʻOumuamua is unavoidable. That first messenger defied classification entirely. Elongated, oddly reflective, and propelled by a mysterious acceleration, Borisov, the second, offered clarity as a comet, its chemistry familiar though its proportions distinct. Atlas, arriving as the third, seemed to inhabit a middle ground between the two. More enigmatic than Borisov, more conventional than ʻOumuamua, it nevertheless forced astronomers to confront the diversity of interstellar debris. Already, with just 3 objects, the spectrum was broader than expected. If 3 messengers differ so greatly, what would 1,000 reveal? The material mystery also carried practical implications. If humanity is to one day intercept or even capture an interstellar visitor, understanding their compositions becomes essential. A rocky fragment may survive high-velocity encounters. An icy body may fragment easily, leaving only dispersed dust. The engineering of future missions depends upon the physics of such objects, and the physics depends upon the chemistry. Atlas, in this sense, was a rehearsal. Though not intercepted, it forced astronomers to refine their tools of remote analysis, to learn how to wring meaning from the faintest of signals. Speculation expanded outward into cosmic perspective. If Atlas is rocky, it may represent the shattered crust of a terrestrial world orbiting a distant star. If icy, it may echo the frozen reservoirs that surround most planetary systems, akin to the Kuiper Belt and Oort cloud of our own. If something stranger, carbon-rich, nitrogen-dominated, or chemically exotic, it may carry within it the first direct sample of alien planetary chemistry, proof that the diversity of worlds is greater than the solar system alone suggests. Philosophically, this invites reflection on origins. Every stone is a witness to the furnace that birthed it. On Earth, rocks record the cooling of magma, the flow of rivers, the crushing of mountains. On interstellar objects, the record is older, broader. Their atoms were forged in stars, bound into worlds, broken free by chaos and sent across gulfs of darkness. To hold such a stone, if humanity could, would be to cradle the history of another star system in the palm of a hand. Astronomers often speak of cosmic messengers. The term is metaphor but also truth, for though interstellar objects arrive without intent, they bring with them data that cannot be obtained any other way. They are emissaries of alien chemistry, carrying clues to the universality, or the strangeness, of planetary processes across the galaxy. They reveal whether water is common, whether organics are widespread, whether the conditions for life are rare or abundant. Each interstellar fragment is a sample return mission conducted by the universe itself, delivered without warning, fleeting in its availability. In this light, the passage of Atlas near Mars becomes doubly meaningful. Not only does it echo humanity's fascination with the red planet, it also offers the chance to study an alien fragment against the backdrop of a world that itself raises questions of habitability. Mars and Atlas become paired symbols. One a mirror of human aspiration, the other a relic of cosmic diversity. Together, they frame the dialogue of science and wonder, reminding us that the search for life is not confined to one world or one system. It is written into the fabric of the galaxy itself. The material mystery of Atlas remains unsolved, and perhaps that is fitting. To know with certainty would end the story. To linger in ambiguity is to allow the imagination to stretch outward, to consider possibilities as vast as the galaxy itself. In the unknown, wonder thrives. In uncertainty, meaning is born. What is certain is this: every fragment that enters our system is a reminder that we are not isolated. The solar system is porous, open to the drift of other worlds. The rocks and ices that fall inward carry with them alien histories, alien chemistries, alien suns. To study them is to glimpse not just other systems, but the shared fabric of existence that binds them all together. Atlas may be dark, ambiguous, and fleeting. Yet in its faint glow, telescopes caught the shimmer of another world's past. And in that shimmer, humanity saw itself reflected, not as the center of the cosmos, but as one participant in a galaxy alive with fragments, each carrying a story, each whispering of suns unseen, each reminding us that the universe is richer than we dare to imagine. The universe does not speak, at least not in words. It offers fragments, motions, alignments, puzzles scattered across the sky. Humanity, in turn, interprets. For centuries, comets were read as omens, warnings of war or plague. In the modern age, they are read as relics, fragments of planetary birth. Yet sometimes, even in the age of telescopes and equations, the question arises that transcends science and enters the realm of philosophy. Could some of these wanderers be more than stone and ice? Could they be machines, artifacts, messages from civilizations beyond our own? This question surged into public discourse in 2017, when the first confirmed interstellar object, ʻOumuamua, swept through the solar system. Its strangeness defied easy explanation. Its shape, inferred from its fluctuating brightness, was elongated beyond anything familiar. Perhaps a cigar, perhaps a pancake, tumbling as it moved. More curious still, as it retreated from the sun, it accelerated slightly as though pushed by a force no telescope could see. Astronomers sought answers. Some proposed exotic ices, hydrogen or nitrogen that could sublimate invisibly, providing thrust without a visible tail. Others invoked radiation pressure, speculating that its thinness might make it sensitive to the push of sunlight. But amidst these natural explanations, one voice broke through with a more radical suggestion. Harvard astronomer Avi Loeb argued that the simplest explanation might be artificiality. Perhaps ʻOumuamua was not a natural fragment at all, but a piece of alien technology, a light sail drifting between stars, or a probe launched long ago by another civilization. The claim ignited controversy. Many scientists criticized it as premature, a leap beyond the evidence. Yet it captured the imagination of the public, for it asked openly what many had quietly wondered. If intelligent life exists elsewhere in the galaxy, then fragments of its activity might one day reach us. Why not now? Why not here in this enigmatic traveler from another star? The debate surrounding ʻOumuamua set a precedent. From then on, each interstellar visitor would not only be studied as a natural object, but also examined through the lens of possibility. Could it too be more than it appears? With the arrival of 3I Atlas, the question naturally resurfaced. Atlas differed from ʻOumuamua in key ways. Its path showed no anomalous acceleration, no unexplained thrust. Its brightness did not fluctuate in ways suggestive of unnatural geometry. It appeared at first glance to be a more conventional body, bound by the same laws of motion as any comet or asteroid. Yet still the question lingered. Could this fragment too be something more than inert matter? SETI, the search for extraterrestrial intelligence, has long prepared for such possibilities. When unusual objects pass through the solar system, radio telescopes turn their ears toward them, listening for signals that might betray technology. With Atlas, as with ʻOumuamua and Borisov before it, arrays scanned the skies, searching for narrowband emissions, repeating pulses, or structured noise. None were found. The silence was profound. Yet silence, scientists remind us, is not proof of absence. An artifact may not broadcast, or its signals may fall outside the frequencies we can detect. Beyond radio, astronomers examined the object's light curve, the subtle variations in brightness that reveal rotation and shape. Artificial structures, especially reflective ones, might flash or glint in ways distinct from natural tumbling. Atlas showed no such signatures. Its light was steady, fading as expected with distance, revealing nothing more exotic than a dark, irregular body. For many scientists, this was enough. The principle of parsimony, the idea that the simplest explanation is preferred, remains central. Natural debris is abundant. Civilizations, as far as we know, are not. To invoke alien technology requires extraordinary evidence, and Atlas offered none. Its path, while extraordinary in its proximity to Mars, was explainable through the mechanics of gravity. Its brightness was dim, its spectrum ambiguous but not unnatural. For most, the conclusion was clear. Atlas was a natural fragment, no different in essence from the billions of comets and asteroids that populate the galaxy. And yet, uncertainty remains. Not in the data, but in the philosophy of possibility. For even if Atlas itself shows no signs of artificiality, the question it raises is larger. Could some interstellar objects now or in the future prove to be artifacts? Could some fraction of the wanderers that cross our skies be the detritus of other civilizations? Their probes, their sails, their debris scattered across the galaxy? This possibility is not idle speculation. Human activity has already seeded its own artifacts into interstellar space. The Voyagers, the Pioneers, New Horizons, all are drifting beyond the solar system, silent emissaries of human technology. To a distant observer, they would appear as faint, tumbling objects, not unlike Atlas. Their artificial nature would be hidden, discernible only through improbable alignments or close inspection. If humanity has launched such fragments within a century of spaceflight, what might older civilizations have cast adrift across millennia? The galaxy is ancient. Stars have lived and died long before the sun was born. If civilizations arose around other suns, their artifacts could already be scattered across interstellar space, as common in principle as natural debris. The odds of encountering one remain unknown but not zero, and so each new interstellar visitor carries with it the faint hope or the unsettling possibility that it might not be entirely natural. Philosophically, this blurs the line between science and imagination. To declare an object artificial without evidence risks undermining science. To refuse to consider the possibility risks closing the door to discovery. Between skepticism and wonder lies a balance, a razor's edge where thought must walk carefully. Atlas itself does not demand extraordinary conclusions, yet the very act of asking the question keeps the mind open, reminding humanity that the cosmos is not only stranger than it seems, but stranger than it can be imagined. The silence of SETI does not end the story. Radio signals may fade, artifacts may lie dormant, evidence may be subtle or hidden. To dismiss the possibility entirely would be premature. Instead, astronomers proceed with caution, acknowledging natural explanations as most likely, while leaving the door open, however slightly, to the extraordinary. In this light, Atlas becomes part of a larger narrative. It is not evidence of alien technology, but it is part of the process by which humanity learns to ask the right questions. It reminds us that each interstellar visitor is not only a scientific object, but a philosophical one. Each challenges us to confront our assumptions about life in the universe, about what is possible, about how we interpret silence and coincidence. For most, the conclusion is clear. Atlas is natural, a fragment of rock or ice darkened by time, drawn briefly into our system before vanishing once more. But for others, the question lingers, not because of what Atlas is, but because of what it represents. It represents the threshold of possibility, the moment when science and wonder converge, and the recognition that certainty is elusive in a universe so vast. The question of artificiality will remain as long as interstellar objects continue to arrive. Each one will be examined, scanned, debated. Some will show anomalies that spark controversy. Others will appear mundane, fading quickly into obscurity. But together they form a new chapter in the human dialogue with the cosmos, a dialogue that asks not only what these objects are, but what they might reveal about the presence of intelligence beyond our world. In the end, Atlas may prove to be nothing more than a rock. But even as a rock, it is extraordinary, for it has crossed the gulf between stars, carrying the memory of an alien sun. It has passed near Mars, the mirror of human longing. And it has stirred, however briefly, the question of whether the universe might one day reveal evidence of minds other than our own. Silence does not end the mystery. It only deepens it. The stars remain vast, the galaxy remains ancient, and the fragments that drift between them remain reminders that the story of life, natural or artificial, may be larger than humanity can yet know. Between the stars lies a gulf so vast that words falter in its measure. Even the closest stellar neighbor, Proxima Centauri, lies over 4 light-years away. That is 40 trillion kilometers, a distance so immense that spacecraft launched by humanity, moving faster than any before them, would need tens of thousands of years to arrive. It is a gulf not of emptiness but of scale, where distances dissolve human comprehension and time stretches into epochs. Into this gulf drift the fragments of creation. When planets form, when stars are born or die, when collisions shatter worlds, debris is cast loose. Some of it falls inward to be consumed by its star. Some remains bound in wide orbits, circling for billions of years in cold storage. But some is expelled entirely, flung outward by gravitational encounters, set adrift on hyperbolic paths that carry it into the interstellar sea. Once expelled, these wanderers travel without destination. They drift for millions, even billions of years, their journeys shaped only by the faint pull of passing stars and the tides of the galactic disk. Atlas, is one such wanderer. Long before the Earth cooled, long before the sun ignited, its story began elsewhere. Perhaps it was torn from the outskirts of a forming system, a fragment that could not find a home. Perhaps it was cast free during the migration of a giant planet, ejected in the gravitational violence that rearranges worlds. Whatever its origin, it has spent uncountable ages moving between the stars, unseen, unmeasured, waiting for chance to guide it near another sun. The improbability of such encounters is staggering. The galaxy contains hundreds of billions of stars, each surrounded by vast regions of empty space. Interstellar objects, though numerous on a galactic scale, are sparse compared to the immensity of the void. Most drift unnoticed forever, never passing close to another inhabited world. That Earth, in its brief span of observation, has detected even 3 such visitors is remarkable. It is as though a grain of sand cast into the ocean happened to strike the hull of a ship. Astronomers remind us that this improbability is softened by numbers. The galaxy is old and the number of ejected fragments may be beyond imagining. If every planetary system produces billions of them, then the Milky Way may contain more such bodies than stars themselves. Their motions are random, but over billions of years, randomness ensures encounters. Earth's ability to notice them is a product of its vigilance, its growing web of telescopes scanning the skies each night, catching fleeting streaks against the dark. Even so, detection remains rare, a triumph of precision against overwhelming odds. To contemplate the journeys of these fragments is to contemplate time on a scale that dwarfs human history. Atlas may have wandered for 100 million years before entering the solar system. In that span, continents on Earth have split and rejoined. Species have risen and vanished. Civilizations have flickered like sparks. To the stone itself, such ages mean nothing. It carries its inertia forward, blind to the epochs unfolding beneath the stars it passes. Yet to human eyes, it becomes a messenger, carrying with it the weight of time as surely as it carries the dust upon its surface. Each interstellar object, then, is more than a fragment. It is a record of processes beyond the reach of human instruments, a record of planetary systems unseen, a record of collisions, migrations, and expulsions that shaped worlds elsewhere. These objects are not sent intentionally. They are not designed to carry meaning, and yet they do. They carry meaning simply by existing, by crossing the void, by revealing that planetary systems are not closed islands but participants in a galactic exchange. The ocean is the closest metaphor. Just as driftwood floats upon the sea, carried by tides and storms, so too do these fragments float upon the currents of the galaxy. Most drift endlessly, their origins long forgotten. A few wash upon unfamiliar shores, noticed by eyes that wonder at their strangeness. Atlas is such driftwood, not sent, not guided, but carried, and in its carrying lies a message. The universe is not static. It is alive with motion, with exchange, with the scattering of histories from star to star. The improbability of detection deepens the mystery. Each interstellar visitor that humanity has seen was nearly invisible. ʻOumuamua was a faint streak, discovered only after it had already passed Earth. Borisov, a comet with a tail, was found by chance through the work of a single dedicated observer. Atlas, flagged by a survey designed to catch near-Earth objects, was recognized only through careful analysis of its hyperbolic orbit. How many others passed unseen? Too faint, too swift, too distant to register. How many messengers have already crossed the solar system without ever being noticed? And yet, despite this improbability, the timing feels uncanny. 3 such detections in less than a decade, after centuries of watching the skies. Some attribute this to technology, the growing power of telescopes, the relentless coverage of the night sky. Others wonder if there is more at play. Perhaps the solar system is currently passing through a denser region of the galaxy, a place where interstellar debris is more common. Perhaps the currents of the Milky Way have guided more wanderers into our neighborhood than before. Whatever the reason, the result is the same. Humanity, for the first time in its history, is becoming aware of the interstellar sea that surrounds it. The distances these fragments travel defy imagination. Trillions of kilometers separate them from their origins. Millions of years pass between their encounters with stars. They drift through darkness so profound that no light warms them, no star claims them, and yet in that darkness they endure. They are durable, silent, unyielding. They are the fossils of motion, carrying with them the memory of the forces that expelled them. Philosophically, their presence invites reflection on the nature of communication. A message is usually intentional, crafted and sent with purpose. But these objects carry messages of another kind, messages not written but inherent. They tell of planetary systems beyond sight. They tell of collisions that shattered worlds. They tell of the universality of physics, the inevitability of ejection, the persistence of matter across time. They tell most profoundly that humanity is not isolated, that the solar system is open, connected to the galaxy not only by light and gravity but by the physical exchange of fragments. This realization changes perspective. No longer is the solar system a closed sanctuary. It is a crossroads. It receives wanderers from afar, and it too casts out fragments of its own. Comets ejected by Jupiter, asteroids hurled outward by planetary encounters, all become part of the same interstellar sea. Some may, in a distant future, pass near other stars, to be noticed by other civilizations, to carry with them the message of this place, this system, this sun. In this sense, Atlas and its kin are mirrors. They show not only what exists beyond, but what we ourselves contribute. Humanity imagines receiving alien messengers, but humanity has already sent them. The voyagers, the pioneers, even small fragments of rock ejected by impacts on Earth and Mars. All are participants in this grand exchange. The interstellar sea is not one way. It is a dialogue, though slow, though silent, though written in stone rather than sound. The scale of this dialogue humbles. Words fail to capture the enormity of trillions of kilometers of millions of years. Yet in that enormity lies continuity. Each fragment, though drifting alone, is part of a larger story. A story of galactic motion, of exchange, of connection. Each carries a message, not sent but carried. A message of existence, of persistence, of the shared fabric of creation. For humanity, to notice these wanderers is to notice its own place in the sea. We are not the only shore upon which driftwood may land. We are one among billions. But in recognizing this, we glimpse the true scale of belonging. The galaxy is vast, yet it is bound together by the journeys of fragments like Atlas. They remind us that across time and distance, the universe shares itself, not in words, not in voices, but in stones that drift between stars, carrying with them the silent memory of alien suns. Every interstellar visitor offers only a fleeting chance. Weeks of brightness, months at most, before it vanishes back into the dark. The arc of Three-Eye Atlas through the solar system was no exception. Yet its path promised a moment that stood apart from the others, a near encounter with Mars. For astronomers, it was not only a curiosity of geometry, but an event that could yield rare and delicate knowledge. Predictions began the moment its orbit was refined. Computers across observatories traced its hyperbolic path forward in time, calculating where it would pass, when it would brighten, and how close it would come to the red planet. The models converged on a moment when Atlas would skim the outer edges of Mars's gravitational domain. The distance would still be immense, millions of kilometers separating object from planet. But in the scales of interstellar drift, it was intimate, improbably so. The timing aligned with Mars and its orbit, placing both planet and traveler in a rare dance across the sky. To the human eye, nothing dramatic would occur. No fiery streak, no visible collision, yet in the quiet language of physics, the encounter was monumental. For the first time, humanity would watch as a confirmed interstellar object interacted directly with the gravitational field of another planet. Astronomers prepared their instruments. The hope was to measure with exquisite precision the object's deflection as it passed. Even the faint tug of Mars would bend its trajectory, altering its outbound course by fractions of a degree. Those fractions carried meaning. They would allow scientists to test models of celestial mechanics on an interstellar scale, confirming predictions and revealing whether unseen forces, such as faint outgassing or subtle radiation pressure, might also be at work. The closest approach promised more. Telescopes orbiting Mars, such as the Mars Reconnaissance Orbiter, could in theory catch a glimpse of Atlas against the black. Although its faintness would push instruments to their limits, the possibility excited planetary scientists. To view an interstellar body not from Earth but from Mars itself would be unprecedented, a perspective that turned the red planet into a second vantage point in humanity's growing dialogue with the galaxy. The alignment also raised deeper questions. Could Mars do more than deflect? Could it, under some improbable configuration, capture the visitor outright? The mathematics suggested not. Atlas' velocity was simply too great. At over 30 kilometers per second relative to the Sun, it carried energy far beyond the planet's ability to bind. To capture such a body would require either immense braking or a rare gravitational choreography involving multiple planets. Mars alone could not achieve it. Yet still the thought lingered. If a planet could capture an interstellar wanderer, the implications would be extraordinary. Such a body would remain as a permanent guest, circling indefinitely, a record of galactic exchange preserved in orbit. Though capture was improbable, alteration was inevitable. The planet's pull, faint as it was across millions of kilometers, would leave its mark. When Atlas departed the solar system, its outbound path would not mirror its inbound one. It would carry with it the memory of Mars's gravity, a subtle deflection that would persist for the rest of its journey across the galaxy. In this way, Mars would write itself into the story of a fragment from another star, joining its history indelibly. The question of impacts added another layer of speculation. Atlas itself would not strike Mars, but could fragments? Interstellar objects, like comets in our own system, may shed material as they warm. Dust and debris, invisible from afar, might drift behind in faint trails. If even the smallest grains crossed Mars's path, they could streak into its atmosphere, burning as meteors or settling as microscopic dust upon its surface. The possibility stirred reflection. If fragments of Atlas rained onto Mars, however small, they would carry chemistry from another star system directly into a world humanity seeks to inhabit. The red planet, already the mirror of human longing, would become a collector of alien debris. Future explorers might one day study such grains, holding in their hands the dust of a planet that once circled another sun. Astronomers treated the speculation with caution. The density of any debris was uncertain, likely too low to produce dramatic showers. Yet even the idea underscored the interconnectedness of worlds. Mars, Earth, and all planets are not closed systems. They are touched by the galaxy, seeded with fragments from beyond, their surfaces dusted with the echoes of distant collisions. As the date of closest approach drew nearer, anticipation grew. Observatories planned campaigns of measurement, aligning instruments to follow Atlas through its passage. Radio telescopes prepared to track its motion with radar. Optical arrays refined its light curve, seeking to constrain its rotation and shape. Infrared instruments searched for traces of heat that might betray hidden volatiles. Each photon gathered would extend the knowledge of what interstellar objects are, how they behave, and what they might teach about planetary systems beyond our own. Philosophically, The encounter became more than a scientific exercise. Mars was no longer just a participant in human imagination. It was now a participant in the galactic stage. A planet long seen as the next frontier of human exploration was also the site of the solar system's first planetary engagement with a visitor from the stars. The symbolism was profound. As humanity prepares to set foot on Mars, Mars itself was touched, however faintly, by a fragment of alien history. The scale of improbability made the moment resonate even more. The galaxy contains uncountable interstellar wanderers, yet only a handful will ever pass near enough to be seen. For one of those few to approach Mars so closely in this moment of human history is remarkable. Science explains it as coincidence. Philosophy reads it as resonance. Either way, the alignment deepens the sense that humanity's story is part of a wider tapestry, one that stretches far beyond Earth. The Martian encounter was not a spectacle of fire and motion. It was quiet, subtle, visible only through instruments and numbers, but in its quietness lay its grandeur. A fragment of another star system, older than human civilization, older perhaps than Earth itself, passed within reach of the planet humanity dreams of inhabiting. It was a meeting of stories. The story of a stone cast adrift in the galactic sea, and the story of a species preparing to expand beyond its cradle. No fragments were confirmed to strike Mars, no capture occurred, and no extraordinary anomalies were recorded. And yet the encounter left its mark. In the data, in the deflection, in the symbolism, Mars became part of the history of Atlas, and Atlas, in turn, became part of the story of Mars, a fleeting visitor that reminded humanity of its connection not only to one planet, but to the galaxy entire. When a fragment from another star drifts into the solar system, it does not pass only through the realm of physics, it passes also through the realm of human thought. Numbers and trajectories are one story, but meaning is another. Each new visitor becomes a canvas upon which humanity projects its fears, its hopes, its skepticism, and its imagination. The arrival of 3i Atlas was no exception. News of the object spread quickly, carried by headlines and digital feeds. For many, the words interstellar object were enough to stir awe. The idea that something had traveled across light years, across gulfs of time older than civilization itself, ignited fascination. Some saw in it the possibility of alien messengers, a theme already seeded by the earlier debates over ʻOumuamua. Others framed it as scientific discovery in its purest form, the cosmos revealing secrets not through deliberate search, but through unexpected gifts. The public imagination moved faster than the data. To most, the object remained a mystery, unseen except in artists' impressions. Yet the absence of detail only deepened the allure. Fiction and speculation filled the silence. Was it a shard of a shattered planet? A frozen seed of life drifting between stars? Or something more deliberate, an artifact designed by intelligence far older than ours? Scientists, meanwhile, responded with discipline. Observatories refined its orbit, telescopes captured its light, and models constrained its properties. Within the community, the debate was cautious but alive. Natural explanations dominated. A rocky or icy body expelled from its native system, darkened by age, deflected by gravity. Yet in the shadow of ʻOumuamua's controversies, the question of artificiality could not be entirely dismissed. The ghost of Avi Loeb's claims lingered, reminding scientists that the line between rigor and speculation is sometimes thin, sometimes blurred by anomalies too faint to ignore. The tension between skepticism and imagination became part of the narrative. On one side stood the weight of evidence, the long tradition of science that favors natural causes until extraordinary proof demands otherwise. On the other side stood curiosity, the human reflex to see meaning in mystery, to wonder if silence might conceal intention. Neither side was wrong. Both arose from the same impulse to understand what it means to encounter something not born of our sun. This reflex to project meaning onto cosmic events is ancient. When comets blazed in the skies of antiquity, they were read as omens, woven into stories of war and prophecy. Today the language has changed, but the instinct remains. When Atlas brushed near Mars, many wondered why. Why this planet? Why now? Science explained it as coincidence, as a matter of probability. But meaning does not always reside in equations. Meaning resides in human perception, in the ability to connect disparate facts into a story. For humanity, stories are as powerful as data. In this way, Atlas became a mirror not only for Mars, but for the human mind itself. Scientists debated its nature. The public imagined its origins. Writers and artists transformed it into symbol. It revealed less about what it truly was than about how humanity responds when faced with the unknown. For in mystery, humanity sees itself reflected, its skepticism, its longing, its capacity for wonder. The debates carried into academic halls and digital spaces alike. Some argued that speculation about artificiality distracted from real science, from the careful gathering of data that alone can reveal truth. Others countered that speculation is part of science, that imagination fuels inquiry, that dismissing extraordinary possibilities too quickly risks blinding us to discoveries. The dialogue was not about Atlas alone, but about the philosophy of knowledge itself, how to balance rigor with openness, skepticism with wonder. For the public, the narrative of alien visitors proved irresistible. The idea that the galaxy might send fragments of intelligence, even inadvertently, resonates with a species that has always looked upward for meaning. From the first myths carved into stone, humanity has sought signs in the sky. Now, in the age of telescopes, the signs are real, objects from other stars drifting silently across our vision. Whether natural or not, they fulfill an ancient longing to know that the universe is larger, richer, and more connected than it seems. This interplay between fact and story shapes more than perception. It shapes funding, research, and future missions. Public fascination drives interest, and interest drives resources. The dream of one day intercepting an interstellar visitor, of sending spacecraft to meet it before it vanishes, grows stronger each time a new object appears. Atlas, like ʻOumuamua and Borisov before it, becomes a stepping stone toward ambitions that might once have seemed impossible. Yet beneath the fascination lies unease. The unknown carries not only wonder but also fear. What if such objects bring danger? What if their trajectories threaten Earth? The same reflex that turns them into symbols of possibility also casts them as potential harbingers. The narrative of alien visitors is double-edged, hope and anxiety bound together in the human response to the unfamiliar. Scientists know this well. They walk carefully between accuracy and accessibility, striving to convey the marvel without stoking unnecessary fear. They explain probabilities, velocities, and distances with patience, reminding the world that Atlas poses no threat. Yet they also acknowledge that interstellar visitors are part of a broader reality, a galaxy alive with motion, where not every encounter can be predicted. The human response, then, is as much about humanity as it is about Atlas. The object becomes a stage upon which ancient instincts play out, to fear, to hope, to explain, to imagine. In its brief passage through the solar system, it carries with it the weight of interpretation. Every headline, every speculation, every debate reflects the mind of a species trying to locate itself in the vastness of the galaxy. And perhaps this is the deepest meaning. Interstellar objects arrive without intent. They are not sent. They are not messages. Yet in encountering them, humanity writes its own message onto their silence. Each one becomes a symbol, shaped not by what it is, but by what we need it to be. A messenger of science, a whisper of other civilizations, a reminder of scale, a mirror of longing. Atlas itself remains indifferent. It follows its trajectory, deflected by Mars, altered by gravity, shaped by forces beyond intention. But the human response transforms that trajectory into story, a story of discovery, of debate, of imagination, a story that reveals not the motives of the cosmos but the nature of humanity itself. The path of every star, every planet, every fragment of drifting stone is not drawn in emptiness. It is written into the very fabric of space-time. Albert Einstein revealed this truth more than a century ago, when he overturned the Newtonian vision of gravity as a force that pulled across distance. Instead, he showed that mass bends the stage itself, curving space and time so that all objects, from galaxies to grains of dust, follow the lines of that curvature. In Einstein's vision, motion is destiny. The arc of 3I Atlas across the solar system was not an improvisation, but a geodesic, the straightest possible line through a space-time distorted by the sun, tugged by Mars, influenced by the faint ripples of all nearby masses. To watch it pass was to watch the fabric of reality guiding its steps, as if the stone were tracing a groove carved long before it arrived. And yet, within that determinism, mystery flourishes. For though the laws are exact, the initial conditions are not. The universe contains infinite complexity, and the smallest uncertainty expands into unpredictability. The trajectory of an interstellar object can be modeled with exquisite precision, yet its origins remain unknowable. Which star cast it out? What collision or migration delivered it into exile? The equations cannot answer. They can only describe what happens next, not where the journey began. Stephen Hawking often reflected on such paradoxes. He spoke of inevitability, of how the cosmos evolves according to laws that admit no exceptions. Yet he also recognized the limits of prediction. Black holes with their event horizons conceal information. Quantum mechanics with its probabilities resists certainty. The universe is governed, but it is not transparent. Its order is laced with unpredictability. Atlas embodies this paradox. Its arrival was inevitable. Somewhere, sometime, some fragment was bound to pass close to Mars. The laws of gravity assured it. Yet for humanity, the timing felt impossible to foresee. A convergence of improbabilities that appeared almost deliberate. Deterministic yet astonishing, predictable yet mysterious. This is the tension at the heart of cosmic motion. Einstein's equations could trace its arc perfectly once it was observed, predicting the deflection of Mars' gravity, the curvature of its hyperbola, the velocity at which it would depart. But those same equations could not reveal why this particular fragment out of billions happened to intersect with this particular planet at this particular moment in history. Physics describes the stage. It does not explain the script. Hawking's reflections extend further. He often considered the inevitability of encounters in a universe filled with motion. Given enough time, every path intersects. Stars drift together, galaxies collide, black holes merge, and fragments like Atlas cross the domains of other suns. The improbability of any single event becomes certainty across eternity. To Hawking, such inevitability carried no contradiction. What seems rare to us is simply a matter of perspective, a fragment of infinity perceived within the brevity of human time. Yet inevitability does not strip away wonder. If anything, it heightens it. To know that Atlas's journey was written into the curvature of space-time from the moment it was ejected is to recognize the elegance of the universe's architecture. Its path was not random, not chaotic, but precise, shaped by the invisible geometry of gravity. And still, to human eyes, it appeared miraculous, a wanderer, from the stars passing close to the very planet chosen as humanity's frontier. The paradox of deterministic motion and chaotic unpredictability reveals itself in every observation. Astronomers can calculate exactly where the planets will be thousands of years from now, yet the weather of Earth tomorrow resists perfect forecast. The laws are the same, but complexity breeds chaos. In the same way, Atlas's orbital elements can be refined to exquisite accuracy, but its deeper story, the star it once circled, the forces that flung it free, remains beyond reach. Einstein and Hawking together framed this paradox. One gave us the geometry of spacetime, the certainty of curvature. The other reminded us of uncertainty, of horizons beyond which information is lost, of the fundamental unpredictability written into the quantum fabric of reality. Between them lies the truth of Atlas, a path that is both inevitable and unknowable, a journey that is both lawful and mysterious. Philosophically, this duality mirrors human existence. Lives unfold according to laws, biological, physical, chemical, yet they feel unpredictable, filled with chance, with convergence, with events that seem improbable, yet somehow necessary. Atlas is not only a stone, it is a metaphor for motion itself, for the way the universe combines strict order with unfathomable complexity. In relativity, the universe is a vast web of geodesics, each object tracing the curvature of spacetime created by all others. Atlas follows one such line, drawn not by choice but by geometry. Yet to human thought its presence feels like a question, a mystery that transcends geometry. This is the paradox that fuels both science and wonder, the recognition that the universe is knowable in principle, but inexhaustible in meaning. The Martian encounter crystallized this tension. Calculations predicted the deflection with precision. Observations confirmed it. Yet the symbolic resonance, the idea that a fragment from another star brushed past the planet humanity has chosen as its future, was not contained in any equation. That meaning arose not from physics but from perspective, from the human impulse to connect coincidence with narrative. Einstein might remind us that there is no why beyond the laws themselves. The path was the natural unfolding of curvature, nothing more. Hawking might counter that meaning emerges in the very act of observing, that inevitability does not exclude mystery, that the universe can be lawful and astonishing at once. Together, their legacies suggest that to seek understanding is not to strip away wonder, but to deepen it. Every interstellar visitor carries this lesson. They are predictable in their motion, yet unpredictable in their arrival. They are inevitable in the long run, yet astonishing in the moment. They remind humanity that it lives in a universe both lawful and poetic, both deterministic and mysterious. The fabric of paths is woven by relativity, but the perception of those paths is woven by the human mind. Atlas is thus more than an object. It is a demonstration of the paradox at the heart of existence. Its trajectory can be mapped with precision, but its presence stirs questions equations cannot answer. It is both inevitable and improbable, both ordinary and extraordinary. It is a fragment of stone tracing the grooves of space-time, and a messenger of wonder reminding humanity that even certainty is mysterious when viewed through the lens of meaning.